Deterministic QuickSort is highly efficient, but vulnerable. If we always pick the first element as the pivot, an adversary can supply a presorted array of 1 to 8. This forces an extremely unbalanced 1 to 7 split at every step, degrading performance to quadratic time. We must break this input dependency. We solve this by choosing our pivot completely at random. In this unsorted array, we select a random index, say, index 4 with value 5. We swap 5 with our final element, 6. Now, we run standard partitioning using 5 as our pivot, ensuring a balanced split on average. Let's look at the implementation. The randomized partition function picks a random index between low and high, then swaps that element with the high element. It then calls the standard partition algorithm. This small change guarantees that the input's original ordering can never trick the algorithm into choosing poor pivots repeatedly. With randomized QuickSort, we achieve an expected time complexity of O of n log n. Because pivot selection depends on random runtime choices, no single input can force the O of n squared worst case. We mathematically guarantee a balanced partition tree with high probability, neutralizing any hostile input.